The periodic table is very useful for remembering valence electrons, valency, charges, types of bonds, and number of shells according to positions of elements in the table. Consider that we zoom in deep enough in salt, that known as sodium chloride. We will not find sodium atoms and chlorine atoms alone. Actually, we will find that they are bonded together. This is because of valence electrons. Valence electrons are electrons in the outermost shell of an atom. All atoms except noble gases have incomplete valence electrons. So, all atoms except noble gases have unstable electron configuration. They participate in bonding one atom to another by losing, gaining, or sharing electrons to get the nearest stable noble gas electron configuration. Noble gases have stable electron configuration because they have complete valence electrons. They don't participate in bonding one atom to another. The number of electrons that an atom can lose or gain or share to get the nearest stable noble gas electron configuration is called valency. If an atom loses one or more electrons, it will become a positively charged ion, that's called cation. If an atom gains one or more electrons, it will become a negatively charged ion, that's called anion. In general, cations are metal ions and anions are non-metal ions. Consequently, ionic compounds are generally combination of metals and non-metals, such as sodium chloride. In contrast, molecular compounds are generally composed of non-metals only, such as water. Notice that the red stepped line that divides metals from non-metals also separates cations from anions. Because anions and cations have opposite charges, they attract each other. This force of attraction between oppositely charged ions is called ionic bonding. However, sharing electrons between two nonmetals is called covalent bonding. Sodium has one valence electron. It has to lose this electron to get the noble gas electron configuration. It would result in the same electron configuration as neon. Due to the loss of electron, a positively charged cation called sodium ion is formed. Chlorine has 7 valence electrons, so if it takes one, it will have 8. Chlorine ion has the electron configuration of argon. When it gains an electron, the resulting ion is called chloride ion. Notice that if chlorine gave up all 7 of its valence electrons and sodium took them, in that case, both would have the electron configurations of noble gases with a full valence electron shell. However, their charges would be much higher. It would be Na-7 and Cl positive 7, which is much less stable than Na plus 1 and Cl minus 1. Atoms are more stable when they have no charge or a small charge. As we can see from the picture, water has 2 hydrogen atoms and 1 oxygen atom. Each hydrogen atom has only 1 valence electron. Each atom needs 1 electron to attain stability. To get the nearest stable noble gas electron configuration, which is helium, oxygen has 6 valence electrons. It needs 2 electrons to attain stability and to get the nearest noble gas electron configuration, which is neon. So each atom gives out 1 electron to share with each other, thus making covalent bonds. The periodic table is very useful for remembering valence electrons according to positions of elements in the table. The group 1A elements have 1 valence electrons. Group 2A elements have 2 valence electrons. Group 3A elements have 3 valence electrons, and so on. Notice that the number next to the A letter indicate valence electrons. The valency of each element in group 1A is 1. The valency of each element in group 2A is 2. The valency of each element in group 3A is 3. They form positive charges because they tend to lose electrons. To get the nearest stable noble gas electron configuration, the valency of each element in group 4A is 4. They form positive charges because they tend to lose 4 electrons. To get the nearest stable noble gas electron configuration, except carbon, it forms -4 ions because it is non-metal. The valency of each element in group 5A is 3. They form negative charges because they tend to gain 3 electrons. Except bismuth and moscovium, they form positive 3 ions because they are metals. The valency of each element in group 6A is 2. They form negative charges because they tend to gain 2 electrons, except polonium and livermorium. They form positive 2 ions because they are metals. The valency of each element in group 7A is 1. They form negative charges because they tend to gain 1 electron. The valency of each element in group 8A is 0 because they don't form any charges, because they don't tend to gain or lose any electrons, because they have stable electron configuration, which means that they have complete outer shell. The periodic table is very useful for remembering number of shells. Elements in period 1 have 1 shell. Elements in period 2 have 2 shells. Elements in period 3 have 3 shells, and so on. Notice that these are valency of each element in a group, and these are charges of each element in a group, and these are oxidation number of each element in a group. For example, the valency of calcium is 2. The charge of calcium is plus. The oxidation number of calcium is +2.